Hello and welcome. This is lecture number 25. In this lecture, we will again discuss on non-contiguous allocation technique. In the last lecture, we had discussed about the paging technique, how paging takes place. In this lecture, we will discuss on segmentation. So let's start. Segmentation, like paging, divides a program into a smaller number of blocks called segments. Right? Now what you have to recall is, in the paging technique we have divided a single process in a particular blocks which is same in the size. Right? Suppose process 1 divided into four different page frame. Page frame number 0, page frame number 1, page frame number 2, and page frame number 3. Right? This is the concept of paging, where process is divided into fixed size of memory blocks. Right? So process 1 divided in 4 different page frames. Each page frame is equal in size. Right? You can consider it. Each page frame is of size 2K. Right? So process divided into equal size of page frame is called pages, and the memory divided into fixed size of block. Right? Now the page frame 0 will stored in a block which is of size 2K. This is called page frame. Right? So equal size of memory is called the block, and the equal size of page frames is called the pages. Right? In the same way, we have to divide a program into a number of smaller block. Right? Here we are not dividing into a process, we are dividing a complete program into a number of smaller blocks called segments. This is the difference between pages and segments. Pages are small chunks of process, where segment is a small chunks of a program. Right? Each of which is allocated to a memory independently. Like page frame stored in that location which of size is 2K. Page number 1 is stored in different location. Page number 3, page number 2, and page number n will stored in different location of primary memory, which is the physical address. In the same way, the segment stored or allocated a memory in independently. Right? Unlike paging, segments are variable size. Responsibility for dividing the program into segments lies with the user or a compiler. The operating system is uninvolved in this case. Right? The hardware sets an upper limit on the size of any segment. A segment table is very similar to the page table. However, since segments are variable size, memory cannot be pre-divided into anything like a page frame. The operating system must maintain a free list and allocate segment to memory holes. The issues of how the allocation is performed are the same as those found in the variable partition schemes. Right? So let's write it. Segmentation. What is segmentation? Segmentation, like paging, divides a program into number of smaller blocks called segments, each of which is allocated to memory independently. तो कंप्लीट प्रोग्राम को यदि हम डिवाइड कर दें छोटे छोटे ब्लॉक्स में, तो उस प्रोग्राम का हर एक छोटा पार्ट एक सेगमेंट कहा जाएगा। सभी सेगमेंट इंडिविजुअली मेमोरी एलोकेट होंगे। सभी पार्ट, प्रोग्राम के सभी पार्ट को इंडिविजुअली मेमोरी एलोकेट होगी। इसलिए आई राइट हियर, डिवाइड a program into a number of smaller block called segment, each of segment which is allocated to memory independently. सभी सेगमेंट को अलग अलग मेमोरी मिलेगी। Now the important thing, unlike paging, segments are variable size, right? Here is the important things. In the paging techniques, each page frame has to be in equal size, right? But the in the segmentation we have different segments, and each segments may have different or variable size. The size is independently, right? So unlike paging, segments are variable size. Responsibility for dividing the program into segments lies with the user, or you can say it may be, this task may be done by the compiler. So that is the responsibility of user or a compiler to make the program into different section or a different segments, right? Operating system will not involved in order to achieve the segmentation. Operating system will not take place here. So let's write it. Operating system is uninvolved. Right? Now the hardware sets an upper limit on the size of any segment. Now the size of segment will decide by the hardware. A segment table is very similar to a page table. So as we had a page table which makes translation of logical address to physical address, in the segmentation techniques we must have a page table. Like a page tables, we will call it segment table, which used for translating from logical segment to the physical segment, logical address to physical address. So we need to perform the address translation as per the segment, right? So address translation must take place in the segmentation techniques. So in order to achieve the address translation, we required segment table, right, which converts logical address to the physical address. Logical address, that is referring to the hard disk segments, and physical address refers to the address of primary memory or a physical memory. Okay. So a segment table is very similar to the page table. Since segments are variable, size, memory cannot be pre-divided into anything like page frame. The operating system must maintain a free list and allocate segments to memory holes. The issues of how the allocation is performed are the same as those found in the variable partition schemes, राइट क्योंकि सेगमेंटेशन में हर एक सेगमेंट की साइज वेरिएबल से चेंजेस हो सकती है, कोई सेगमेंट किसी साइज का, कोई सेगमेंट किसी साइज का. So we can have n number of segments and each segment must have a different size, may have a different size. So the allocation of memory to a segments, that means it is very typical task because we don't know the size of the segments, right? So first we have to arrange the free holes, then we apply enforce some policies, you can say, as we had discussed in the last lecture, maybe best fit, maybe worst fit, maybe next fit, or maybe first fit. So we have 4 different policies to allocate a partition in dynamic, right? Maybe we can use first fit, best fit, next fit, and the worst fit. We have 4 different policies we already discussed in that policies. So we can apply any one of these policy into the segmentation, right? So we are applying because we have variable size of partitions, we have different variable size of segments. That is why we have to enforce any one policy from among, right? So this is segmentation. So segmentation, like paging, divides a program into number of smaller blocks called segments, each of which is allocated to a memory independently. Unlike paging, segments are variable in size. Responsibility for the dividing the program into segment lies with the user or a compiler. Operating system is uninvolved in this case. The hardware sets an upper limit on the size of segments. A segment table is very similar to the page table. Since segments are variable size, memory cannot be pre-divided into anything like a page frame. The operating system must maintain a free list and allocate segments to a memory holes. The issues of how the allocation is performed are the same as those found in the variable partition schemes. So how the segmentation will take place? Let's try to understand in the graphical representation. Let's have a look. Again we have 4 different entities. CPU, this is the logical address format, segment number, and limit. Right. We have segment table which contain 3 important columns. First, segment number, second, segment limit, and base address of the segment. Right. There is some conditions we must check before translating the address. If the condition is true, then we will go on the physical address. That means the translation of the address will be successfully. Maybe there is condition false. At condition false, we will not translate the logical address to physical address. Right? After translating successfully, the logical address converted into physical address via adding something. Now what is the entities which is being added and makes a physical address of the segment? We will go further. Right? So these are some entities. Again, we have the physical entities. In the physical entities, there is a starting address of the segment. We have segment 0, we have segment 3, segment 2, segment 4, segment 1. As you can see here, in the physical memory, the segment 0 starting from the base address 1400 and closing is in 2400. Now if you subtract the upper limit minus lower limit, you will get the limit of segment 0. How many lines contained by the segment 0? So 2400 minus 1400, that is difference is 1000. So we can say segment 0 contains 1000 line of code. So we are interested to load any segment dynamically into the physical memory. Right? Now you can consider another diagram like segment 0, 1, 2, 3 and 4 are situated in somewhere into the hard disk. Right? You can consider here this is the hard disk in which segment 0, segment 1, segment 2, segment 3, segment 4 are situated with the logical addresses. Right? Now we are interested to load any segment from hard disk to our physical memory. Right? Now how we can do this? This is the question. How we can do this? So any part of the program which is stored into the hard disk or secondary memory, what happen if that program loaded into the physical memory? How this will take place? Who perform this task? Who generate the logical address? Who are responsible for translating the logical address to physical address? Right? What kind of condition we need to check? What is the value which will be added? So these are some questions which are question mark right now, but after the end of the discussion you will get everything. So let us start. Each entry of the segment table has a segment base and the segment limit. This is the segment table, segment base address and segment limit. The segment base contains the starting physical address where the segment resides in the memory, whereas the segment limit specifies the length of the segment. As you can see here, the base address 1400, that is the base address of segment number 0, limit 1000 line. Maybe it is line of code, maybe it is byte of code. So 1000 line of code, 1000 bytes of code, you can consider it anyone. Okay, segment 0, the base address is 1400. As you can see here, the base address is 1400 and I'm talking about the segment 0, so you have to mention the segment 0. In the same way, segment 1, right? Now find out the base address of segment 1. This is the physical memory, this is the segment 1. Base address is 3600 and the limit is, the closing of segment 1 is 6700. Subtract 6700 minus 6300, will get the difference, will get how many a line of code in segment 1. So we will get, after subtraction, the segment 1 have 400 line of code. In the same way, segment 2 which have a limit 400, that means segment 2 contains 400 number of lines which start from the 4300. right? Segment 2, that is segment 2 starting from 4300, that is the base address, and this is ending address of the segment, right? In the same way, segment 3 containing 1100 and the base address is 3200. 4, segment 4 containing 1000 line and base address is 4700, right? So the segment table containing the three different part: segment number, which signifies the number of segments which we are talking about; limit, which contain the length of the segments or line of segments, how many lines the segments can have; and the base address, how the segment is starting from, where the segment is starting from, segment कहाँ से start हो रहा है, right? Let's have a look in the next way. Right, a logical address consists of two parts. CPU always generate the logical address for the any segments stored in a hard disk, and the logical parts contain two parts: segment number, this is S, and the offset into the segment, this is offset. So S is the segment number, D is the offset. किस segment से कौन सी line को load करना है, right? In which number of lines we are interested to load into the primary memory. So first we have to know about the segment number, then we have to know which number of lines. Okay, because each segment have different limits, right? So we have a very specific requirement, that means segment 0 containing 1000 lines and we are interested to load 900 number of lines, right? So we can do these things in that way. A logical address consists of two parts: a segment number and an offset into that segment. The segment number is used as an index into the segment table. This is the segment number working as an index number. The offset D of the logical address must be between 0 to the 0 and the segment limit. This offset is very important parameter. This parameter the value must reside in the limit, in between the limit. If it crosses the limit, that means we are not able to generate the physical address. That means if any segment, like second example like segment 0, if it contain 1000 line of code, we cannot generate 1002 number of lines. We can generate the physical address 0 to 999, that is 1000 lines. We can generate the physical address inside the range, inside the limit. Okay, I hope you get my point. So offset address is very critical parameter which identifies which limit address is valid and which limit address is invalid, right? Can we generate the physical address or not, that is decided by the offset values, right? If the address reside inside the limit address will be generated properly. If the offset values is reside or exceed from the limit address, that means the physical address will not generate it. So let's have a look how we can do these things. The segment number is used as an index into the segment table. The offset D of the logical address must be between 0 and the segment limit. If it is not, we trap to the operating system. Logical addressing attempt beyond end of segment. If the offset is legal, it is added to the segment base to the produce the address in physical memory of the desired byte. So if the address is valid, offset is valid, it will add with the physical address and load into the primary memory. If it is not, the base address will not added in the logical address. Let's have a look. Consider the following examples. We have three different examples. The CPU generate logical address 1200. This is divided into segment 1, offset 200. you can consider is that is the logical address generated by the CPU containing two different part. First segment number and second is 200 byte offset. We are interested to load 200 line of code 200 lines of code situated at segment number 1, because segment number 1 containing 400 lines of code और मैं interested हूँ 200 नंबर की लाइन को लोड करने में, right? So let's have a look how it will take place. Right, as you can see here, लॉजिकल एड्रेस को फिजिकल एड्रेस में कन्वर्ट करने के लिए वी मस्ट हैव अ सेगमेंट टेबल, क्योंकि सेगमेंट टेबल से ही हमें बेस एड्रेस पता चलेगा, लिमिट पता चलेगी. पहले हम लिमिट को चेक करेंगे बाइट ऑफसेट से. यदि बाइट ऑफसेट छोटा हुआ लिमिट से तो हम एड्रेस ट्रांसलेशन के प्रोसेस को आगे बढ़ाएंगे. अदरवाइज लिमिट यदि बाइट ऑफसेट यदि बड़ा हुआ, एक्सीड हुआ, तो हम यहीं पर उसे ट्रैप कर देंगे. राइट, दैट इज चेक्ड बाय the condition, which is very important. Segment 1 is accessed in the table. Now access that segment number 1. This is segment number 1, limit 400. Take the values 400, 400, 200, that is the byte offset which we are interested to load into the primary memory. So byte offset is must be less than equal to limit, not equal to, always be less than. So 200 is less than 400. Yes, condition is true. Yes, we can translate that address with 200 line of code and we have 400 line of code. 200 must be reside in between 400, 0 to 400. So we can do these things, right? So segment 1 is accessed in the table and the offset 200 is compared to the limit 400. 200 is less than 400. Yes, if it is less than limit, what we can do? Yes, condition is true. Now we have to add 6300, the base address coming from that partition, coming from the segment table. Now the 6300, that is base address, will add it with the byte offset. So 6300 plus 200, that is 6500, go on this location and access the 200 line of code. So उस सेगमेंट से 200 नंबर की लाइन को आपको एक्सेस करना हो, आपकी लोकेशन आ चुकी है. फिजिकल एड्रेस इज 6500. दिस इज द सेगमेंट 1. दिस इज द स्टार्टिंग एड्रेस 6300. दिस इज द एंडिंग एड्रेस 6700 and your physical address will situated somewhere else 6500. You can go on that location, access the 200 lines and do whatever you want to do, right? In the next example, let's have a look. Logical address is 3 and the byte offset is 250. Logical address is 3, byte offset is 250. Complete logical address is 3250, as you can see. Now get the values from segment 3. Limit is 1100, byte offset is 250. 250 is less than 1100. Yes, condition is true. Generate the physical address. अब physical address generate कैसे करना है? Take the base address 3200, add with the byte offset. So 3200 plus 250, physical address is 3450. Now it will situated somewhere else. This is, so we are talking about segment number 3 and we are interested to load or access line number 3450. So we will go on that location, put the line, load into the primary memory, or we can access, it is depend up to the user interested to read that particular line or user interested to write on that line. User can perform read and write operation on that location, right? So we have to find the location, that is our task. Whatever the operations user intended to perform, it is up to user. right? Let's take another example, how operating system trap the user requirement. Now this is example third. CPU generate logical address 2500, segment number 2, byte offset is 500. We are interested to load 500 number of lines in the segment 2. पहले चेक करिए सेगमेंट 2 में लिमिट कितनी है. सेगमेंट 2 लिमिट है 400 लाइन्स और हमें 500 नंबर ऑफ लाइन्स को लोड करना है. इट इज़ नॉट पॉसिबल. सो देखिए कैसे ट्रैप होगा. ऑपरेटिंग सिस्टम के थ्रू ये एड्रेस ट्रांसलेशन नहीं किया जाएगा क्योंकि बाइट ऑफसेट इज ग्रेटर देन टू लिमिट. So segment 2 is accessed in the table and the offset 500 is compared to the limit 400 and 500. 500 is less than equal to less than 400. No, it is not less than. It is greater than. So what we can do? Trap by the operating system, and the logical address will not convert it into physical address. It will not added with the base address of the segment, and the finally address will not generate it, right? So this is actually the segmentation, and that is the hardware which support the segmentation. I hope you getting my point. Thank you.